All right, Algebra 1B students. Welcome to part 2 of lesson 12.4 on box and whisker plots. We're going to start taking all these numbers we've been finding in data sets and turning them into a plot, a box and whisker plot that kind of shows us the range or the distribution, you could say, of a data set. Now, one quick side note that I didn't remember to put in the last video is here about interquartile range. It just means the difference between the third quartile and the first quartile. So to find the interquartile range, we just subtract the third quartile minus the first quartile. Make sure that this gets in your notes. Third quartile minus first quartile means interquartile range. And then we are ready to move on to box and whisker plots. Okay. Now, a box and whisker plot is something that we draw on a number line, and it shows us 5 numbers which we now know how to find. It shows us the minimum value, the lowest data point. It shows us the maximum value. It also shows us the first quartile, the third quartile, and the median. Okay. Now, between the first and third quartile, we draw this box here. We draw a box between the first and third quartile. Then we mark the median right here with a straight vertical line through that box, sort of cutting our box into 2 other boxes. This is why we call it a box and whisker plot. The box is here between the first quartile and third quartile with a bar at the median. And then there is a whisker down to the minimum value. We just go with a straight line straight down to the minimum value. And there's also one from the box up to the maximum. So we connect the first quartile, which is the lower end of our box, down to the minimum value, and we connect the third quartile up to the maximum value. Okay. So here's a couple of things to write down in your notes about this. The left whisker extends from the minimum to the first quartile. So that's minimum to first quartile right here. Then we have the box that goes from the first quartile to the third quartile and has a vertical line through the median, so that's how we mark the median. Okay. And then the right-hand whisker extends from the third quartile up to the maximum. Right. And then each of these sections, you could say, each represent a 25 or so percent of our data. Okay, so we have a 25% of our data points from the minimum up to the first quartile, which means the first quartile is really our 25th percentile. If we remember that percentile means how much is equal to that or lower. There's another 25% here between the first quartile and the median in that lower half of our box, 25% there as well, which means our median is now at the 50th percentile. And then there's another 25% from the median up to the third quartile, which makes our third quartile the 75th percentile. And then 25% is found in this upper whisker, the right-hand whisker as well, from the third quartile up to the maximum, 25% of the data there. So we obviously have all 100% of our data points up to our maximum value. So the box and whisker plot shows us the distribution and how kind of spread out things are on a number line, or how closely packed all of our data points are very nicely and compactly. Okay. So now let's go ahead and make a box and whisker plot ourselves. I've got this data set here, the monthly sales of audio devices. And I'm going to make a box and whisker plot for this data set. Now the first thing that I can do is plot a few of the points, the minimum and maximum things, but I'm going to start by finding my median so I know where all of my points need to go. So I'm going to start marking things off here, and my median is right here between 14 and 15. So 14.5 is my median. I'm also then going to find my first and third quartile by looking at my lower half, finding the median here, mark off the 4, 14, 10, 8, 9 is my first quartile. And then I'm going to do the same from here up, my top half, across the 15, 34, 16, 25, and 16 is my third quartile. Right, and obviously my minimum value is 4. My highest maximum value is 34. So I now have these 5 numbers which I am going to use to create my box and whisker plot. Okay? I found the median, I found the quartiles, and now I'm going to mark all 5 of these numbers. 0, 2, 4, I've been counting by 2s here. So there's 4 right there. That is my lowest point. 9 would be here. That's going to be the lower part of my box. The median is going to be here. That's also going to be a vertical line. 16 is my my third quartile. 16 is right here. And then my highest point is all the way up at 34 here. Okay. So I'm now going to create this box where I already have the median marked. And then I'm just going to connect from my box up to my minimum and maximum value. Okay. So I've now created a box and whisker plot which shows me my minimum value, my first quartile, my median, my third quartile, and my maximum. Okay, so each of these 5 numbers, minimum, first quartile, median, third quartile, maximum, all become part of my box and whisker plot. Okay. Now I've summarized the steps for us to create a box and whisker plot here. 4 steps. I don't think any of them are that complicated. Most of them we already know how to do. The only thing that's new in this video is this last step here of actually making the box and whisker plot. Okay. So our 4 steps are, again, to find the median, then find the quartiles, and then plot these 5 numbers. Minimum, first quartile, median, third quartile, maximum. And then make the box around the first quartile and the medians, and the median, and then our whiskers to the minimum and maximum. Make sure these get in your notes, and then we will move on to just the other type of question we might see in our practice problem set. And those questions are going to look something like this, where you are given maybe 2 box and whisker plots and asked to use them to compare the 2 monthly rainfalls. Okay, so they give us monthly rainfalls for an entire year in different number of inches. How many months are in each, or how much rain is in each month. So they have Miami, Florida, and New Orleans, Louisiana here. And what we need to notice is that these 2 box and whisker plots look very, very different. The first thing we can compare is the center, which in this case is the median. There is a higher median rainfall in New Orleans, so we might say on average there's more rainfall in New Orleans. But then we can look at the first quartile and third quartile, basically look at the size of our box, and say in this case that the middle 50% or right around the average rainfall for New Orleans is much less spread out than it is in Florida. Right? Sometimes in Florida it's actually quite common to see very low rainfall, very high rainfall, whereas in New Orleans it's pretty compact. So the main thing that I would want us to get from this these 2 box and whisker plots is not only is the overall range in Miami much more spread out from here to here, but the inner quartile range, which maybe gives us a little bit better idea, leaving out outliers and things like that, of where our typical rainfall is. The typical rainfall in Miami is much more spread out than it is in New Orleans. So your book puts it this way: the middle 50% of Miami's rainfall varies much more widely than those in New Orleans. So Miami is much more widely varying, or much more spread out, or something like that, is what I would like to see you write in these kinds of situations. Okay? Now, if you have questions about how to create a box and whisker plot, like I said, make sure those 4 steps get in your notes. I'll be looking for that tomorrow. If you have questions about how to interpret a box and whisker plot, any of the parts of them, please make a note to ask me in class tomorrow those things. Otherwise, that's all I have for you for tonight. Have a wonderful night.